Hello and welcome to our today's compact webinar from the MiniBear Intech Academy. My name is Michael Meyer, and today I'm not the speaker, I'm hosting today's session, and I will sit in the background and support you within the chat function and the questions function with your questions, concerns, and feedback. Before we start, two technical details. You probably already have recognized that all your microphones are muted, and this is by purpose. The intention for this is that we can concentrate on our speaker fully, and the intention is also to guide you to our second topic, the question box. If you open the GoToWebinar tool, you will find on the bottom a section to chat and to ask your questions. Make sure to ask your questions at any time. I will support you for this. We expect probably 30 minutes of presentation from our today's speakers, two of them, and later on we will have 15 minutes of Q&A session. We will, of course, use your questions to discuss them in the Q&A session at the end of the presentation. So, enough from my side. I guess it's time to introduce the first speaker. Welcome, Yannick. Nice to see you.
Thank you, Michael. And hello and welcome everyone to the webinar Loadcell, a central heart of weighing applications. My name is Yannick Salzmann. I'm product manager located in Hamburg. And together with my two colleagues here, I'm responsible for load cells, the fitting accessories, and weighing electronics. Today, I'm here with our application specialist, Michael Kral, who will introduce himself after my short introduction. First of all, I would like to show you today's topics. We will start with a technical background and the technology of strain gauge load cells, before we will get some insights in the portfolio of weighing components by MiniBear Intech. Afterwards, we would like to show you some practical-oriented weighing examples of applications we realized. In the end, I will summarize today's webinar, and I will show the benefits of weighing solutions by MiniBear Intech. But first of all, to make it easier for you getting into this complex topic, I would like to refer to the title of the webinar, Loadcell, a central heart of weighing applications. Most end customers actually don't know that the sensor behind their weighing application is a load cell with a strain gauge technology. Depending on the requirements of the application, the load cell could have different shapes, as you could see in the blue circle in the middle of the slide, but still using the same technology, which Michael will explain in a minute. The reason that many customers don't know the load cell is that it's mostly hidden in a scale or machine. So on the left side of the slide, you will see machines and products MiniBear Intech is manufacturing themselves in other locations. On the top picture, you will see a check weigher where the load cell is integrated below the belt for measuring the weight of moving items, which is called dynamic weighing. Below, you will see different industrial scales. It could be platform scales, bench scales, or floor scales. In general, they are working similar to your body or kitchen scale at home, just engineered for highest precision and rough industrial conditions. These two applications, as well the machinery, we are talking about lower capacities. The accuracy is mostly about grams, the capacities more about kilograms. If you look at truck scales, for example, only one load cell is for capacities from 30 or 50 tons. And as well, vessel or silos for storage or dosing applications, for example, have a wide range of capacities from 100 kilogram up to dozens of tons. When I'm talking about a weighing solution, I mean that the end customer has a weight value he can use in his production process. Therefore, more than just a load cell is needed. You always need some kind of mounting for the load cell. It could be the scale could be designed for integrating the load cell, or you need external mounting kits, for example, for silo constructions. As well, normally you have more than just one load cell, and so you need to combine the several analog signals from the load cells to one sum signal, which you can process afterwards. This will happen in the cable junction box. Afterwards, this sum signal will be forwarded to weighing electronics This could be a transmitter, which you connect directly to your PLC, or you could get a controller, which has own programmed control applications for your specific requests. But now enough from me. We will take a step back to the technical background, and I would like to hand over to my colleague, Michael Crown.
So, hello everybody, and thank you, Yannick, very much. I'm Michael Kral, application and training specialist for Tech and Hopper and industrial scales and Minibia Intec. I've been working for the company for over 24 years now, 21 years as service technician, and over 3 years in my current position. But actually, I've been working in the weighing business for pretty exactly 40 years this year. But now our more interesting topics. First, I would like to talk about weighing sensors and accuracy consideration. The most often used principle of weight sensor, especially in the industrial environment, are strain gauge load cells. These load cells offer economical and effective solution for determination of weight value. Further benefits are the robustness and durability, even under difficult conditions, and also availability of high capacities. The resolution is mostly specified with up to 60,000 display intervals, of course not for legal for trade, but if required, can be even higher depending on the conditions of the installation. And beside the load cell specification, also the quality of evaluation electronics is very important for the possible maximum resolution of the weighing results. The construction is relatively simple. The force, the load of the weighing pen or weighing platform applied on the measuring element, also called spring body, generates elastic counterforce in this measuring element. The deflection of the spring body is registered in the strain gauges firmly attached to its surface. The resistance of the strain gauges will change depending if being strained or compressed. The change of the resistance is measured and evaluated by the evaluation electronics, an indicator, transmitter, controller, and so on. The result of the evaluation is the weight value readout in the display. The basic principle is the combination of 4 strain gauges in circuit, so-called Wheatstone bridge. The strain gauge or the strain foil strain gauge increases its resistance. The compressed one decreases its resistance. An input voltage for the load cell will be provided by the evaluation electronic. For example, 12 volt, what is usual for example, Maxis 5. The measuring signal output voltage of the load cell will change depending on the load position on the scale. Output without load, also without that load, only the empty load cell will be always 0 volt. Most used specification for load cells is the 2 milliwatt per volt, which means 2 milliwatt signal load cell output using 1 volt supply voltage load cell input. This specification describes the maximum deflection of the load cell. The load cell is being loaded with the maximum capacity. The comparison on the right-hand side shows the thickness of these strain gauge foils. Compression load cells offer many benefits. They are very robust against overload, less sensitive against side forces than other type of load cells. The load cell with a rocker pin principle will return to the correct upright position automatically due to its restoring force. The nominal deflection of the measuring element is between 0.3 and 1.4 millimeter. Excuse me. Actually, the elastic deformation of the spring body. These type of load cells, as our new model Inteco, are also often called canister load cells. The mentioned rocket principle protect the compression load cell against side forces and also against possible damage. This is one of the benefits in comparison with bending beam or shear beam load cell. The side forces have also less impact on the accuracy of the weighing results if we're using compression load cells application. The definition of accuracy. Accuracy is the extent to which the displayed value approaches the true value of an object based on the scale. Accuracy is influenced by many factors such as resolution, repeatability, linearity, uncertainty of measurements, and many others. The main difference between accuracy and repeatability, we have defined the accuracy already. Now the repeatability is the ability to determine, evaluate always the same results of the measuring procedure if the measuring procedure is being repeated, independent of the accuracy of the results. Also, results with deviation can show a good repeatability if the indicated deviation is always the same. The high accuracy is essential for a constant quality of the production. The poor accuracy will have a negative impact on the whole production process, considering both possible additional cost and lower quality of the products. What can be done to improve system accuracy? Proper planning and consultation before developing a new installation comprising weighing instruments, using high quality components such as load cells. Yes.
One second. Can you please check? We are not anymore in the presentation mode of your presentation.
Okay, I was wondering, there was some funny indication. Is it okay now?
Yes, I can now see accuracy of weighing instrument.
Yeah, it's okay. Yeah.
Thank you.
Now I lost my trace. Yeah, what can be done to improve the system accuracy? Proper planning and consultation before developing a new installation comprising weighing instruments, using high quality components such as load cells, indicators, cables, and junction boxes. Also, minimizing environmental influences will help to improve the performance of the weighing system and its accuracy. These possible influences can be air current, temperature fluctuation, vibration, humidity, electrical interferences, and so on. The first consideration, of course, is the specified accuracy class of the selected load cells for the installation. This will predefine the performance ability of the weighing system in general. Menibia Intec offers load cells with accuracy classes up to C6. On this slide, in the upper table, we can see different accuracy classes with their typical resolutions. The lower table provides an overview of achievable system accuracy, provided proper installation, of course, and usual applications for these accuracy classes. The accuracy of a scale or weighing instrument in operation is different from the load cell accuracy. Mechanical and environmental influences have an impact on the accuracy, of course. As a manufacturer of components, such as Menibia Intec, can only specify the accuracy of its components, load cells, evaluation electronics, and so on. The system accuracy needs to be defined at the beginning of the designing of the weighing instrument, such as process vessel. The largest permissible deviation of a component during, for example, filling application will determine its this required accuracy system. Very important consideration, accuracy is not the readability of the weighing instrument. One essential part of the installation of load cells are mounting kits, ensuring the correct position of the load cell and providing protection against the external forces, such as horizontal forces and thereof generated lift-off forces. Without protection, the vessel could tip over and fall down. In many cases, the mounting kit also provides overload protection for the load cell. Again, correctly selected and installed mounting kit have also a high impact on the system accuracy. Now I would ask my colleague Yannick to take over again. Please, Yannick.
Thank you, Michael. In the next chapter, we would like to have a closer look to the portfolio of weighing components by Mini-Bear Intec. I will start with our compression load cell, which Michael explained already in the chapter before, which are mostly used for silo and vessel weighing. We have different accuracy classes starting from L, which is mostly for level measurements, up to C6, which is for high precision dosing applications. The capacities of our compression load cells starts with 30 kilograms for the ultra-flat load cell, up to 520 tons for special applications. As we always have the whole solution in mind, we are not just looking for these key facts, but as well for the customer needs. For example, an easy installation with the additional functions of our mounting kits, or special requirements like hygienic design for the pharma and food industry, or load cells for hazardous areas or X applications, for example, for the chemical industry. As well, we have digital solutions, which I will mention a bit later. Besides the compression load cells, we have single point load cells and beam type load cells in the portfolio. These have normally lower capacities, starting from 5 kilograms up to 5 tons for the beam type load cells. Single point load cells are normally used in check weighers or platform scales. As the name assumes, you use just one load cell for a weighing application, so you use it alone or single. It is then centrally placed below the platform. Beam type load cells can be used for scales as well, but again with normally 4 load cells under one platform, or for smaller silos and vessels. We have a portfolio of truck scale load cells as well, or truck scale solutions. In general, it is a compression load cell or canister type load cell, which is the same as I showed before, but for truck applications, some special requirements are needed. For example, a lightning protection, as the truck scale normally is placed outside. It is good to have this lightning protection, so you don't have to replace the load cell after every bad thunderstorm. Of course, we have all the fitting accessories for truck scales and the fitting weighing electronics with special truck applications. As I said in the beginning, the end part of the weighing application is the weighing electronics to process your analog signal from the load cells to get a weight value which you can process in your production process. Therefore, we have 3 different kinds of electronics. I will not explain the technical details, but show some differences. On the left side, you see the weighing transmitter. It is normally on a DIN rail hidden somewhere in a cabinet in your production area and process the data or forward the data from the load cell to your PLC. We have all popular field buses in the portfolio as options. In the middle, you see the X3 indicator, which is actually the same technical design as a transmitter, just in another housing with display and soft keys. This allows a local use of the weight value and doing settings at your application. The high performance product for our weighing electronics are our controllers like the Maxis 5. Here, this Maxis 5 is programmable and can control up to 4 scales, has plenty of inputs and outputs or interface cards, and is equipped with an internal web server for perfect connectivity. Together with our software, MiniBear Intec is helping reduce waste, minimize errors, and ensure high product quality. The intuitive user interface ensure easy operation and minimize training requirements. Now I would like to show one of our new product highlights. Therefore, I will switch to a video. I should just start. Now I think I should be back, and with the next slide I will show another new product, our converter Connex. Added to our load cells, you will get a digital solution, which means that the output is digital with a standard protocol CAN open. It leads, for example, to faster propagation times and individual communication with the load cells, which is really helpful for the service technician, for example. Among others, you don't need a cable junction box anymore, which makes the commissioning faster and easier. With this product, we focused on the customer needs to make the work at every step easier and offer more reliable weighing options. Please let me show now some examples for our installations of weighing components. Therefore, I will take a role as manufacturer of instant coffee who wants to install a dosing scale, but actually don't know much about weighing. So I figured out some inputs which I thought could be helpful for MiniBear Intec. For example, that the net capacity of my silo is 200 kilogram, and the dead load in general with the silo is 300 kilogram. The vessel has 3 legs, so I guess that we need 3 load cells, and the system error should maximum be 300 gram. So, Michael, are there any external influences I should consider beside that? And do you have a fitting solution for me?
Thank you, Yannick. Thank you very much. Yeah, now I'm back again. Of course, there are many considerations what has to be viewed before the planning. All the environmental conditions in the place of installation, especially the temperature fluctuation, because there is the one of the biggest impact on the accuracy. The evaluation electronics is very important, of course. Some additional apparatus, is there some agitator, mixer, some heating element, and so on. This will be the first consideration, and of course, the complete environment of the production area has to be considered. I think I can show you something with our first example, which only partially fits, or fits with some exceptions. In this example, we can see X3 indicator with easy fill application. A discharge vessel installed on Indeco load cells using, sorry, I think we have a small problem, technical problem. Michael, can you please confirm me? Can you see the presentation again?
Yes, it works well again.
Yeah, thank you. In this vessel, we are using Indeco load cells, using PR6143 mounting kits. This would be the exception I mentioned, because these load cells are mostly for higher maximum capacities. But as example, this could be used. The load cells are connected via PR6130 junction box to the AD converter of the indicator. And the digital outputs can control the valve during the filling. I mentioned before this would not fit exactly for the requirements, but it is approximately one example how this installation can look like. We can also connect more than one weighing points to one controller or indicator. In this example, both vessels are controlled by a Nexus 5 controller. The display can toggle between these two readouts. The Indeco load cell is installed by means of high-performance PR6001 mounting kit in this case. If no display is required at the place of installation, or only auxiliary one, we can also offer our transmitters for such kind of installation. The PR5230 transmitter offers, beside very high ingress protection IP66, also many options such as field bus interfaces or analog output to connect, for example, PLC. The integrated load cell in this example is our hygienic design Novego, as Yannick mentioned before, which do not require any mounting kit for the installation, only dedicated accessory. More complex procedure can be realized with our controllers. The Maxis 4 controller can control various storage silos with IBC or batching application. This can be either one or more component filling, manual, automatic filling, and so on. The broad connectivity can be used to adapt the weighing instrument in the production process. Even more complex procedure can be operated with our Maxis 5 controller, with up to 4 weighing points implemented in the batching process and utilized simultaneously. The connection and options are even more extensive with the Maxis 5 controller. But not only filling procedure, but also, for example, truck application is available with the Maxis 5 controller, with comparison weighing between empty and full truck statistic, reporting, and so on. Additional apparatus such as barriers or traffic light can be controlled by the Nexus 5. Our dedicated truck load cells are the best option for this installation. Now I would like to ask my colleague Yannick again to take over.
Yes, thank you, Michael, for showing these applications. And now we are close to the end of this webinar. I will just summarize some key facts again. And therefore, I would like to tell you that the load cell production of most of our load cell is right next to me here in Hamburg. And here I can see that our load cell accuracy is a result of perfectly controlled production processes. One example, therefore, is the matched output, which means that the output signal is always adjusted to the same value. Together with the outstanding linearity and hysteresis of our load cells, allows it to calibrate MiniBR Intec load cells without weights. The result is 100% accurate load cells. In general, as you could see in this presentation, the products by MiniBR Intec are helpful in every step of your production lifecycle. Load cell, scales, checkweighers, or inspection machines. These products support you to have an efficient and safe production process to reach a result of the highest quality. The wide portfolio of MiniBR Intec leads to the expertise of our engineering and sales team, knowing the whole process of weighing components from strain gauges and load cells up to whole scales and checkweighers. Therefore, we can always support you with your specific questions. We have a global team of sales colleagues, application specialists, and even certified partner to support you all around the world. In addition, we have 6 showrooms to make virtual presentation and trainings, while traveling is really challenging in these times. Just have a look at our homepage, minibr-intec.com. Now I'm at the end of the presentation. I hope I could bring you closer to the topic of load cell as central heart of weighing applications. And now I'm happy to get your questions or feedback. And I would hand over to Michael.
Thank you very much for your presentation. Thank you, Yannick. Thank you, Michael Kral. It was very interesting, and I also received some questions from the audience. But before we start, maybe let me answer a question which came in. The question was, can we have the presentation? And if you look into the GoToWebinar tool you have on the site, you will find a chapter named Handout. If you open it, you will find today's presentation available for download. And if it doesn't work on your hand, feel free to contact us at any time using our email address, academy@minibr-intec.com, and we will make sure to send you this presentation. Not only the presentation, also if you have questions coming up after this event, feel free to contact us using the Academy address at any time. But let's start with the questions. So the first question probably is kind of simple. How can a customer or a user determine a possible resolution of a weighing instrument? What should he do for this?
Yeah, hello everybody again. The highest resolution will depend, of course, on many factors. The first, as already mentioned, will be the load cell, the accuracy class of the load cell, and the evaluation electronics. And if you see the specification of our evaluation electronics, you see a value for the minimum voltage or minimum signal per display interval, and this will actually define the maximum resolution you can get. Of course, this is the theoretical resolution, what you can set, but if it is realistic to use it on site will depend on the complete installation.
Thank you very much, Michael. 2 questions also about accuracy. So first is like, what is the best accuracy I can achieve with the load cells you have presented? And the second one is, you have mentioned different accuracy classes in your presentation. What are they referring to? Is there some kind of international rule about the classes? Is it something internal? Can you give us details about those 2 questions?
Thank you for the question. The maximum resolution Was it the first one? I'm not sure if
the best accuracy to achieve.
The best accuracy, sorry. The best accuracy again will depend on the selected load cell, evaluation electronic, the complete installation, all components they are there, and of course from the complete installation, all mechanical influences has to be avoided. The environmental influences limited as much as possible, and these are this will be first the theoretical calculation, what you can get with our components, and the real accuracy actually can be only determined by calibration on site, because you see how the complete installation is working. And the accuracy classes refers actually the legal for trade approval, and are defined with C3, C4, C6, and so on. D1 is the lowest one for legal for trade. There are also some accuracy classes as L and so on. They are not for legal for trade. And maybe you remember the one slide with the comparison where the maximum resolution are defined according or referring to these accuracy classes. And if you are using the load cells for legal for trade application, it is of course very limited what you can use given by the approval. If you are using not legal for trade, then you are quite free. But of course, the higher accuracy class is better, has better specification, and better results can be expected.
So when you say legal for trade, it means there is an international standard for those classes. It's not that we have to compare the different producers. If we have a C3, it's the same C3, all others also categorize. Or is it producer specific?
No, this is international or IML and approval. It refers to the international specification.
Thank you very much, Michael.
Mm-hmm.
You have, I guess it was you, Michael, in the beginning of the presentation, you showed us the different types of load cells, and you also mentioned the different, let's say, technologies like strain gauge technology and EMFC. In a few words, can you summarize what is the real difference between both, and when should I go for which?
Thank you. Yeah, the most difference is the strain gauges are simpler, mostly also the cost consideration, because they are not that expensive, but for higher capacities, if you are talking about tons, then you can only select strain gauge load cells. More robust and more resistance against some influences. EMFC is the so-called electromagnet force compensation system, is used for higher resolution. We are talking about hundreds of thousands of digits display intervals for industrial scales, and for lab balances we are talking about millions of digits. Actually, we have 20-30 million of digits. The resolution is higher, but the system itself is more sensitive against vibration, temperature fluctuation. Also, overload is much easier to be destroyed, and also more expensive. And EMFC weighing system are mostly for only kilogram maximum capacity. We have weighing platforms, the biggest one, 300 kilogram maximum capacity with EMFC system.
Thank you very much, Michael. We in the last question, we spoke a lot about accuracy, but you also mentioned readability. Can you just summarize again what readability means? And maybe as a second question, what exactly is the correlation between accuracy and readability?
This is very important consideration, because there is sometimes some confusion about this. Readability is the smallest display interval. We are also talking about the digits. That is very common expression, but this display interval or deviation, the smallest digits, what I can recognized in the display of the weighing instrument. And the accuracy is actually how accurate is this displayed value. And if we compare the readability is never the accuracy, because we have some influences, rounding errors, and so on. And if I expect accuracy, for example, at least 1 kilogram, then some simple rule is to say I need at least 10-fold higher resolution to see 0.1 or 100 gram as a display interval to be able to recognize the 1 kilogram correctly.
Thank you very much. The question which just came in is, can you maybe explain the difference between the readability and repeatability?
What was it? It's repeatability?
Yeah, the first one is readability.
Excuse me.
And the other one is repeatability, yes. So to repeat the measuring.
I was not listening correctly. Readability is the display interval, and repeatability is also mentioned in the presentation. Repeatability is the ability of the weighing instrument to display always the same result. If I put a load, for example, 10 kilogram on the scale repeatedly over and over again, then I expect always the same readout. Yeah, if there are some differences between these actions, then this will be poor repeatability. And I expect always the same, and it doesn't matter if it is accurate or not, but it should be, it's supposed to be always the same.
Okay, so how can I use a good repeatability when I do not have a good accuracy? How does this works together?
This is a very good example. You maybe know our comparator scales, where you compare actually some reference sample. It is, for example, used for adjustment of test weights. You have a reference sample and you put it on the scale, remove it, and put another sample which you compare with. And the accuracy is given with the reference sample, not with the scale. And in this case, the readout doesn't matter. The accuracy of the readout is not necessary, but it has to be always the same result. And the comparator scale is actually the best example for very good repeatability, but could be also poor accuracy.
Thank you very much, Michael. We only have 3 minutes left, so let's maybe switch the topic from the weighing basics to applications. So the question is, yeah, we have seen the different controllers and electronics to operate in different applications, but can I have more than one application on the different controllers? What is the approach we have?
It depends on the electronics, but if you are talking about controllers as Maxis 4 and Maxis 5, there is always only one application. It is only fetching, only IBC, only track, and so on. We have also another indicators such as convex with some basic simple applications, and these applications can be combined. But if you are talking about electronics such as controllers, it is always only one application.
Thank you very much. More specific question about the truck scale. We have seen your slide was the truck scale application for the Maxis 5, if I remember well, and 4 different load cells. The customer is curious about how detailed this application is. So, for example, you can manage the weighing process, of course, but can you also manage the different weighing steps, like full truck, empty truck, and maybe also the truck itself and drivers, like managing those kind of data afterwards? Or is it more focused on the weighing approach?
Both, actually. The weighing application can manage the complete data. This is actually the part of the truck application. And I mentioned already the statistic, the evaluation. Mostly it is installed in some area where the full trucks are coming in and empty coming out, or another way around. And you compare these values, you record it, you have reports printed and also stored on the PC. You can communicate with some database, operate some additional devices as the barrier and traffic light. And what I missed to mention before, we can also fill the truck on the truck scale. There's also additional function for filling. There could be some container with material, and the truck can be filled on the truck scale.
Thank you, Michael. We are already a bit late, so let me please ask the last two questions before ending today's session. Truck scale, very short question. All the functions you have mentioned, is this all included in the controller Maxis, or will there be a separate software on top?
This is everything in the Maxis controller, but only Maxis, this application, as I mentioned, bridging IBC truck, it is only for the controller available. I also mentioned the Easy Fill application. Easy Fill will be available with transmitters or with the X3 indicator.
Thank you very much, Michael. Last question for today, mounting kits, completely new topic. How do I choose the right mounting kit? There are so many. What do I need to consider, maybe very roughly?
This is very interesting question. Of course, if you have some specific requests, we can also support you with recommendations. The most consideration is what kind of protection do you expect? There are side forces mostly. The side forces are protected with constrainers. The constrainers are also important to keep the position of the vessel, of the mounting kits. Then this lift-off protection, if there are some side forces stronger, they could create a danger, then the container or vessel could tip over. Then this will be protected with lift-off protection. We can also integrate it overload protection. Some mounting kit has checkup functions. And for the selection, it is do you need all these kinds of protection at once? And of course, how high are the side forces or the forces in general? For example, even for wind or earthquake, this has to be calculated. Which mounting kit is fitting the best. This is quite a complex topic, and for some specific requests, we can of course support you.
Thank you very much, Michael. So we are running out of time. We're already late. So for those who haven't received their answer yet, we will make sure to send you your answers via email after this session today. If you have more questions which you didn't ask yet, feel free to contact us, academy@minibia-intech.com. We will be there for you. So I have to say goodbye and thank you to Michael and Yannick for today's presentation. Have a good day, everybody, and thank you for joining.
Yeah, thank you. Thank you for your attention. Goodbye, everybody.
Goodbye.